Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning. Okay, class, we would like to continue our lesson in numerical methods to topic 8 about ordinary differential equation. Okay, for the learning outcome of this topic, the student will be able to understand the difference of initial value problem and boundary value problem. So basically, in this topic ODE, ODE can be divided into two, which is initial value problem and boundary value problem, BVP. Okay, for this IVP and BVP. So for IVP is divided into several methods, which is around 4. Okay, we have Euler method, modified method, and Range-Kutta as well. And BVP also divided into 2, which is will be explained in the next session of the video recording version. So, and then second learning outcome of this topic is student will be able to apply the numerical method to solve the ordinary differential equation. Okay. For 8.1 is about the understanding of ODE. Okay, ODE in which is involve the derivative of one or more dependent variable, in which respect to a single independent variable is called as a ordinary differential equation. So in this case, because involve of derivative of one or more, so in this case there are some in this case we have one more. In this case we have y, z, and this one is got one is on the x. So in this case, this equation is related to the ODE. Okay, ODE also can be divided into 2, which is IVP, initial value problem, which is only one. Okay, we have a graph here, and then we have a set of data, but the boundary also only which is we just only know about the y value only at this at the starting point. Okay, y. So in this case we know what is the x and what is the value of y. Okay, this is what we call it IVP. Okay, dy dx is f, x, and y. This at x equal to 0, at x 0, and then y equal to y naught is maybe 6, 7 or something like that. And for BVP, boundary value problem, we know all these things. We know at x equal to 0, y equal to 1, meaning that we know the value of the y at the when x equal to 0, and when x equal to L, let's say 10, let's say, and then we know what is the value of the y at YL location. This is what we call it boundary value problem. You know all we know the value of those n for first and last, as compared to the IVP. We only know at the starting point. So if an ODE is accompanied by auxiliary condition, at the same value of independent variable, this type of problem is termed as initial value problem. And the auxiliary condition is referred to initial condition. On the other hand, if the auxiliary equation are known at different point of the independent variable, we are dealing with a boundary value problem BVP, and the auxiliary condition are referred to as boundary condition. Okay, okay, we go to the figure 8.2 about the example of vibrating mechanical system, where we can see here we got vibrating mechanical, which is damper and spring. Okay, this is a mesh, and then this is the deflection or the distance, and this is about the velocity. Okay, so already encountered frequently in engineering. For example, consider a mechanical system as shown in here. When this mechanical system is disturbed by heating with the initial velocity V naught. Okay, say we put some disturbance value. Okay, for the phi, the mass vibrate. Hence, the equation of motion can be written as this one. Okay, so M is a mass, dVdt is considered A, okay, and C, okay, multiple by V, and Kx. So this one and this one is considered the system of this vibrating mechanical system. And initial condition of V naught, okay, V naught equal to V naught, meaning that at X condition, okay, at equal to 0, and we know what is the condition of V naught, the initial velocity. By solving this IVP, we can know the velocity at a certain time. Let's say t equal to 5. So let's say t equal to 5. For example, the different method used to solve the IVP can be discussed further in the following section. Okay, so we go to the first method, which is we call it in Euler method. Okay, measure value problem by using Euler method. So in this method actually, okay, let's say we have dy dx, okay, or y prime lah, okay, equal to f, x, and y. So we will know we have to know the value of x and y. And the point is y when x equal x naught and y equal to y naught, the initial y0. So by using Euler method, each solution can be given by, okay, in order to identify the current or the next, okay, y x I plus 1, then we have to know the summation of the yx and plus h multiplied by y prime x. Okay, let's say, okay, we go to example x 8.1. Okay, we have this one. Okay, we have this function which is 2y prime plus 3y equal to e power of 2x. So in this case, the first step is we should rearrange the equation to be, okay, only y prime only. So 2y prime is equal to e 2x minus 3y, and then divided by 2. Okay, so from this we know about the equation for y prime. So y prime here you have to multiply by h in order to get this one. Okay, h is the step size of the increment of this one. Okay, from 0 plus 0.2, the step size. Okay, so from this question actually the condition is where y equal to 1 and x equal to 0. So when when y equal to 1, x equal to 0. Okay, and then by using Euler method, okay, the increment of h is 0.2, and they are asking us to solve or to identify the y value when x equal to 1. So in this case, Okay, we start the x from 0, and then the step size is 0.2 until x equal to 1. So the question is asking us about to identify what is the value of y when x equal to 1. Okay, so this is the answer, but basically during iteration we don't know this one first lah. Okay, we don't know this one. Okay, so in this case, how we are going to get this one? Okay, this number is by calculator. So first we press the calculator, and then we identify the number of h1 prime, meaning that, okay, from this one, okay, we change all the x equal to 0, okay, and y equal to 1, okay, and then multiply by h is 0.2, okay, and then we will get minus 0.2, and then in order to identify the next, okay, yx, so you have to use this kind of formula, okay, by adding yx plus hy prime, meaning that you have to add, okay, this number, okay, this number plus this number, okay, and then you will get the current value of yx, this one, okay, and then from here you identify the number, okay, the value of hy prime, okay, as follow this one. So x, in this case x is 0.8000, and then y is equal to from the previous okay, sorry, x is equal to 0.2, y is equal to 0.800. So in this case, and then you have to multiply by 0.2 each value, then you will get minus 0.0908. So the rest process is same, where we know about the iteration is up to when x equal to 1. Okay, so this is the answer. The answer is 1.08 for y. Okay, when x equal to 1, y equal to 1.08. And this is the validation process by using free math. Okay, free math. Then we just copy the function actually, and then in order to identify the when x equal to 1, then y equal to 1.08. Okay, and then we proceed for the next method, which is what we call it second order Range-Kutta, okay, midpoint or improved Euler method. Okay, so midpoint method, okay, we call it midpoint method, is the improvement of the Euler method. Okay, consider an initial value problem at first order first ODE lah, or ordinary or first order ordinary differential equation. So in this case we have a dy dx, where we also denote as a f function, and x and y, okay, or and this one is y when x equal to 0, and y at y initial y 0. So by using midpoint improved Euler method, its solution is given by, okay, we have 4 equation here. First we have the function itself, where f, okay, is xy or y prime is same, and then we have y when I plus 1 is equal to y plus k. So in order to identify, in order to determine, okay, the yi plus 1, the recent value of y, we have to plus, okay, we have to do summation between the value of yi at the moment yi to the plus k2, okay, the value of k2, and we have k1 and k2 formula. Okay, so we straightforward go to the example 8.2 as a given as initial value problem as follows. So this is the equation given in the question. So from this you have to process, okay, but okay, you have to process. Okay, before that, this is the condition. Okay, in this case y bracket 0 means that when x equal to 0, this one, when x equal to 0 and then y equal to 0, so y equal to 0, this is the condition related to this statement. Okay, so again I repeat again. When x equal to 0 and then y equal to 0, when x equal to 0 here, 0, then y equal to 0 here. Okay, and then solve the initial value problem using midpoint method. Okay, for x is between 0 to 1, so you have to iterate from 0 x, okay, from 0 until 1. Okay, and h is 0.2 as same as before previous example. Okay, subsequently check your answer using Freeman. Okay, this is the validation process. So for the solution, first we have this equation, okay, dy dx, okay, minus 2x power apa ni, multiple by 2y minus 1, okay, equal to 0. So you have to process this, rearrange this statement to be like this. Okay, this is considered y prime, dy dx. So we just do some rearrangement of the formula, and then this, okay, based on this, okay, we know that the equation for y prime is 2x, okay, multiplied by 2y minus 1. Okay, this is the formula that we will use later on. And the second formula is about k1, and this last one is k2. So for k1 is slightly straightforward. Okay, we just multiply h with this function. Okay, we just multiply h, meaning that this equation multiplied by the h value. H value is 0.2 here. Okay, 0.2. Okay, and then for k2, okay, you have to do some substitution, okay, where we multiply the h with the function of x, where the x itself, okay, the x itself, you should plus h over 2, and for y you have to plus k1 divided by 2. So in this case, let's say, okay, in this case, for f x y is equal to 2x, okay, and then 2y minus 1, okay, and then for k1 is equal to, okay, this term, okay, 2x, okay, multiplied by 2y minus 1, okay, and then you have to multiply by h. For k2, all this x should be plus h over 2, meaning that equal to, okay, 2, okay, all the x, so x is x plus h over 2, okay, and then multiply by 2, okay, y. So y is y plus k1 divided by 2. Okay, all any y you have to plus k1 over 2, any x you have to plus h over 2. Okay, and then multiply by h. Okay, so that's it for k2. Okay, then okay, in this case from x is given 0 and y equal to 0 and x equal to 1, but we don't know this one. This one the final value that we want to identify. And for k1, okay, just key in the calculator and change all this number. Okay, the x here, okay, change maybe using green in color. So in this case for any, okay, for k1 to x, so x here is okay, 0. Okay, x is 0, y is equal to 0. Okay, and then we will get this value lah for k1. And for k2, all the x is 0 and y is equal to 0 as well. But k1 is equal to okay, 0 seems. Okay, what else? Okay, and then you will get minus 0.04. All this procedure, all this iteration is repeating. Okay, and another thing that I want to highlight is, in order to identify the next value of y, okay, because the x is the summation is follow h value. Okay, h is equal to 0.2, then the x is start from 0, 0.2 plus 0.2 is equal to 0.4, 0.6, 0.8 and until 1.0. But for y, you have to follow this equation. Okay, okay, this one. Okay, this equation. So yi plus 1 equal to yi plus k, meaning that in order to identify this value minus 0.04, you have to summation between the value of y, the previous y is equal to 0 plus, so this one is y I plus k k2 k2 k2i lah. Okay, k2i. So y y I plus 1 lah. Okay, equal to yi plus k2. So in this case yi is this one 0, and then k2 is equal to minus 0.04, so plus minus 0.04. So in this case we will get minus 0.04 for y value, the next y value. And then again this process and another process is repeating as same as the previous formula, previous procedure. Okay, and this is the validation through free math software, where we just copy all these things. Okay, let's say for the k2, okay, this is the function for k2, and then we put the value of a is 0, value b is y, okay, is 1, then okay, y not is 0 and h is 0.2, okay, 0.2. So Okay, good. Okay, I think enough for this topic until midpoint method. And for the second order range quota using Hune method, I will uh, go for the next session. So enjoy the video, enjoy the class, and we will meet during the tutorial. Okay, tutorial class where you can discuss and ask me anything about this related topic. Okay, thank you. See you. Bye. Assalamualaikum.